Hello, my name is Zineb Faiq. I'm an architect and BIM professional and currently completing a postgraduate master's degree in BIM and digital construction. In this video, I'd like to share with you a prototype I developed for my dissertation titled Enhancing Data Consistency in IFC Export Workflows, a semi-automated AI agent workflow for error detection and suggestion corrections. So it's like an exploratory solution that combines openBIM standards, automation, and AI. And let's get started. As you know, maintaining data consistency in IFC files is very critical for interoperability and collaboration. In today's construction industry, openBIM has become a cornerstone for enabling collaboration between stakeholders using different tools and platforms. At the heart of openBIM is the IFC Industry Foundation Classes format, which acts as a neutral language for sharing model data. But despite its importance, IFC exports from BIM authoring tools often contain inconsistencies. These issues may result from misconfigured export settings, missing property sets, custom naming conventions, or even human error. So such inconsistencies can compromise interoperability between tools and teams, create ambiguity in downstream users like in 4D, 5D, or even facility management phase, and also it delays the coordination and decision making. That's why data consistency in IFC model is not just a technical detail, it's very critical. It's a critical enabler for reliable, efficient collaboration in digital construction. This project aims to respond to this challenge through 4 key objectives. First is to identify the frequent inconsistency patterns in IFC model exports, such as misnamed parameters, missing attributes, etc. Second is to explore the use of AI techniques, particularly the machine learning and natural language processing, to support automated detection and correction suggestions. Third, design and implement a semi-automated AI agent capable of analyzing structured IFC data and generating context-aware correction suggestions. And then evaluate these workflows' effectiveness through testing, and we're going to test this in a real IFC model. So let's get to the workflow overview. In the next few minutes, I will walk you through the complete process from exporting an IFC model to analyzing its data and triggering an AI-based correction suggestion. Let's get started. Okay, so let's begin with a model created in Revit. So Revit is the BIM authoring tool that we're going to be using in this demonstration video. So before exporting the IFC of this model, let's just ensure of a couple of things. So let's check the IFC parameter settings. So here we see that we're selecting a wall and it's correct, so it's exported as a wall, and then the predefined type is standard, and then the GUID, which is the IFC GUID, actually it refers to the globally unique identifier. It's automatically assigned to each element in IFC. So this is correct. So what I want to do before exporting, and this will be very useful in our demonstration, is that I will select, for example, this wall as you see here, and I'm applying IFC beam, which is not correct. So basically here we should have exported as a wall, because it's actually a wall, not an IFC beam. So this is one of the errors that I'm doing actually deliberately, so that we can test this workflow. Okay, so once we're ready, now we can export this file in the IFC format. I'm gonna name it IFC model A. Okay, so IFC model A, and then we can set the sets for IFC reference review as an MVD. So IFC 4 reference review architecture setup, and then we can export it. Okay, so once we have our IFC model, now what we can do is that we can open BIM Vision. So BIM Vision is a free IFC viewer that enables you to verify the structure. So let's open our file. There you go. So basically now what we can do, we can check properties. So here, for example, if I'm selecting this wall, so now we have the information related to the IFC entity, the object type, etc. We can also have, of course, the quantity takeoff information. We have the location. So each element, that's why it's important to have such tools that enable you to view information. So that's how we can. So here, if you remember, this is attributed to IFC roof, which is false. So that's a beam, which is not the case as well. So these issues actually may not be immediately obvious when viewing the model, visually, but they can cause problems later. So that's why it's important to have an AI-powered consistency check. Okay, next, so we move into Google Colab. So Google Colab is a cloud-based environment provided by Google that allows you to write and run Python code directly in your browser. So you don't really need to install anything locally, and it's very useful. So in this step, what I'm going to do is that I'm going to use IFC OpenShell. So IFC OpenShell is actually a powerful Python library specifically designed to read and manipulate IFC files. So I'm just having the first command to run, which will enable me to have here the possibility to manage the IFC file. I'm going to load it here. So once it's launched, then I can have access and I can add the file here. Okay, so now it's going through the installation process here. Okay, so once we're reading that it's successfully installed, okay, so now I can just add here and upload my IFC files, which is the IFC model A that we just exported. Okay, so here is our file. Okay, so once we have our file and we have the IFC OpenShell activated, then I'm just gonna go and run a code. So I'm just gonna pass in a Python code script built with the help of ChatGPT. So I just provided a prompt describing what I wanted in terms of extracting all IFC elements, and then IFC helped me build all these Python code. So what I need to do actually is that I need each time, because this is a template code that I can be using I can use actually for many other file types. So here we have the IFC model A, so we need to make sure that here we adapt this and we make sure that we have the IFC model A as well here. Okay, and it's creating an Excel workbook, it's getting all IFC elements, filling the rows, and then we'll save the Excel file, and then I need to provide the name here of the exported file. So just let's name it data IFC. Let's keep with A as well. Okay, so basically if everything is correct, when I'm gonna be running this code, so normally how it works here, I might have here the errors. If not, I'll just have exactly, so it was correct. Because sometimes the mistake that can be made is, for example, you need to make sure that capital letters are aligned with the same name. Okay, so now we have our Excel file created based on the script. So let's check, let's download it, and then let's check. Okay, let's just make this wider. Okay, so basically we have now all the information, so it's more than 900 rows from this model that are exported with the entity type, the identifiers, the name, the object type, and the predefined type. So actually this Excel file becomes the structured data set that feeds directly into the AI agent workflow in the next step. So let's go to the next step. Okay, so next we move to N8N, which is an open source low-code automation platform that lets us visually, as you see here, design a workflow by connecting nodes. So these are nodes and these are connectors. So each node actually is performing a task. Yeah, so it's like building block in the chain, passing structured information to the next one to keep the process traceable, modular, and scalable until we have our actual results. Okay, so the process starts when Google Colab sends the extracted file, Excel file, to this webhook URL. So it's the trigger actually that enable the starting of the workflow. And to do so, what we need actually is we need to connect the collab to the N8N. So in order to do so, back to the collab platform, I will pass another part of the script, Python script, to enable me to have these link and link the webhook URL and link both of them. So here basically I just need to be consistent in the naming files, which is really important. So we named the file data IFCA. Okay, so we need to make sure that it's correct. Okay, and then what also we need to do back to our because actually the same workflow can be used in many files in many other workflows within the same platform. So each time the flexible points are the files namings that we can change, and of course we can have them as inputs here, but also the actual NAN webhook URL can be changed as well. So let's get the one for this actually. So I open by clicking 2 times, I open this first node, and here I just like click on listen to test event, which will give me the link. I need to copy it, and back to my collab script, I'm just gonna pass in this link and run the script. So this connection is created. Great, so once it's done, it's connected, and here we have our file. So you can spot here data IFC. Okay, so now we can start actually, as we have in our input here, we can carry on for the rest of the workflow. So the second node, the extract from files here. So what will enable us, we're just clicking on test step. So here basically what this node is doing is that it reads the file, the Excel file, and then row by row, okay, and converts it into structured data that can be processed. Okay, so it's done. Okay, so these elements will get through what we call a pre-processing code node. So again, this is a code node, and with the prompt-in, we're just asking him to apply some light pre-processing, like formatting values, filtering empty fields, or normalizing terminology before passing it to the actual AI agent. So here again, we're just gonna test this step, and it's done. Now we have our outputs. Okay, so now let's go to the main analysis node. So here the AI agent. So this is the core actually of the workflow. It connects to, as you see here, the AI chat model, which provides reasoning and language understanding, and a simple memory model, which keeps track of previous prompts and results to provide consistent, context-aware answers. Okay, so when we open the node here, actually, we have the prompt. So the agent is prompt to analyze each row, detect inconsistencies like naming errors or missing types, and suggest corrections in plain language. So here, for example, I just also added some, like mentioned in the prompt, that it might be some French or other languages, because it's the case here. I'm working in many languages, so I just want the AI agent to be consistent in languages as well. And you should bear in mind that this prompt is also something that you can add layers on and add more information on and work on it and develop it throughout the process. So let's just test this step. So basically what's happening here is that the AI agent is using the OpenAI chat model and storing also the simple memory, and then processing actually the actual analysis, data analysis. Okay, so here, as you see, once the AI agent has responded, right? So this node actually restructures actually the output. So it's typically like merging the original data with the AI suggestion, etc. So here again, we have JavaScript code that's that's guiding these needs. And actually, I can either click here on text step to see the output, or I can click here on test or execution the workflow. So basically it's done. So we can see that here we have 55 items, right? So the convert to file is the final node that we have in this actual workflow. So it converts the results back into a downloadable Excel file, which includes both the original entries in the AI agent corrections and suggestions. So let's run it. Once it's done, I'm opening it to see the output actually, and here I can still check the file name. So let's have like results A. Okay, run it again so that we have actually what we want as the name. We gotta download it, and this is the output we're having. So once we open the Excel file, so here actually you have the row. Okay, so it has been filtered, and here we can have issues that were detected. Let's just keep it here. So basically, if you remember, we have spotted the IFC beam, right? And here we have the issue, and actually as the AI agent used the prompt and used the logic behind it, and now we can have even his suggestions. So here, for example, we have this entity type IFC beam, and the name actually, it was a wall. And then we have the issue, the name indicates a wall, but the entity type is IFC beam. And then we have the suggestion to change the entity type to IFC wall. Same goes for the chimney that we used for the one of the doors. Same goes also for a curtain wall. But here we have another type of errors. We have like we need to define a valid predefined type for this curtain wall elements. Here also it's the same, kind of the same problem. So we have to change the entity type. Okay, we have some missing object type. We have, so all these errors are spotted through these AI agents. So this is actually the output we're having. Okay, so now what we can do is that let's just spot two. Okay, let's just correct these two first errors, for example. Okay, back to the authoring tool and see, run again and see the consistency of things. Okay, so back to the original file in Revit. As we're having here, we want to apply some corrections as suggested by the AI agent. And to make things easier here, you can actually select this ID elements and directly go to select by ID. So it will enable us directly to get through what we want. So as you remember here, it was IFC beam. So let's just correct it and keep it as IFC wall, standard. Okay. And the second one was the door applied to IFC chimney. So let's get again the ID here. This is the door. Okay. And I'm just gonna change this to the right one, which is the IFC door. Okay, so now we corrected these two mistakes that was spotted as suggested by the AI. And now actually I'm gonna export another IFC file. This time it's gonna be called IFC model B. Okay, using the same preset parameters. Okay, now back to my original collab workflow or platform, and here I'm just gonna add this new model. Okay, here you go. And before running again the script, as I've explained before, I need to be consistent in the naming. So it's the IFC model B, and then the outcome I want it to be data IFC B again. And going through the next part as well of the workflow to just keep it consistent and having the right naming of the outputs here. Okay, so basically I'm just gonna run it. It's just gonna run the two parts as well. And here we have our IFC data IFC B file. Okay, so if you remember, I need to connect these two platforms. So I'm just gonna get back to webhook, and now I'm not using this file actually, so I need to click again to listen for test event and go back here actually. And as it's the same workflow, so I'm having the same link, I'm just keeping it. I'm just updating and running again, and here you go. And here we have data IFCB. Okay, so instead of going one by one as we did before, now that we have an idea about the workflow, we're just gonna run it all at once. Okay, now that it's finished, then I'll go to the convert file node and make sure that I rename the file output here for the second row to results B. I'm just gonna test it, and then now I'm sure I have the output file as results.b in terms of naming. So let's just download it, and we're gonna open it. So here's the previous one, and this is the new one, results.b. So again, making this wider. Okay, now I just put them beside, so results.b and results.a, so that we can see here. If you remember, we had the two first rows were related to these errors that we corrected, and we run it again, and now we don't have these two errors anymore. Okay, so it's really useful, and now we can really spot the results and comparing the results. Okay, so the workflow actually is designed to be modular, as you've seen. We can still, by getting this link, keeping this, actually, it's better to rename this and make it like IFC to Excel export, for example. And it can be also saved through the drive, Google Drive. Okay, and so as I said, it's modular, so we can keep loading different files, different IFC files. It just needs to be updated through the scripts and the prompts to be able to detect the actual file. And regarding the actual NAN link, actually, it's always the same method. So you can still work on listen to event, and then if you're working on another workflow, you can still use the link, copy, and then paste it here to have the results aligned. Okay, so that's the overall workflow. Okay, so what this workflow actually offers is not just a technical prototype, but a concept of hybrid intelligence combining AI with BIM expertise. So it has the potential to save time on repetitive validation tasks, improve consistency in project data, and support more reliable openBIM collaboration across disciplines. Okay, so to wrap up, this demonstration was meant to show what's possible when we combine openBIM automation and AI, and more importantly, to sparkle discussion. So I would genuinely appreciate your professional feedback, whether it's about the technical structure of the workflow, ideas of improvement or extension, or even potential use cases in your practice. So you'll find a QR code on screen that links to a short feedback form. Feel free to scan it and share your thoughts. It would mean a lot, and it will help me continue refining this concept with the industry in mind. Thank you for your time and attention.